Good evening, everyone. For my first question is from yesterday's session. Anyone is having any doubt till now? Any doubts from anyone? Okay, Rishite told no. Anyone? Okay, I hope it's clear for everyone. So today we'll be picking up only RDBMS. I mean today onwards. Okay. Uh,
I have a question
yeah, please.
uh, doubt on foreign key and the primary key.
Okay, tell me. Okay, do you want? I mean, I'll be elaborating the same thing today. Today we have the
Okay,
topics again.
sure.
We have the
Okay,
topics of keys in SQL. Okay.
okay, okay.
I'll be just telling these things. If still the doubt is exists, please tell me once more time. I'll be trying to clarify with some example. Okay. Okay. So what we are going to cover in today's session, we'll be picking up RDBMS. We started to learn what different kind of, how we are storing the data with the different kind of data representation. It's relational database. It's NoSQL database. It can be a graphical database, okay, where we are creating charts and graphs, this kind of thing. So today onwards, we'll be picking up RDBMS. On top of RDBMS, today we'll be learning how we can normalize data. Okay, so data normalization is today's topic, main topic. Then we'll be learning again, with some more details with the keys in SQL, just like primary key, foreign key, composite key. This is one more key I'll be trying to say. Then how we can handle the data in relational database. So we need to store the data in the database. The same tables into database that we'll be learning today. I will be taking a new database for our hands-on part. I'll be telling you a link to install your MySQL database in your system. After that, we'll be just going ahead with a few things. I'll be opening MySQL database from my system and I'll be showing you what are the different kind of objects we can see over there and all. And I'll be just also requesting you to install the same thing at your systems. So that Monday onwards, it's totally hands-on class. So whatever we will be coding over here, can practice the same during our hands-on. Okay. Okay. Let's start the topic. Just give me 1 second. 1 minute. I'm just coming. Okay, I'm back. First of all, data normalization. What is data normalization? Whatever data we are receiving from the source side means from the transactional system, the data is not normalization in nature. But as a data engineers, our role is when we are pulling the data from the source system and pushing it to meaningful target data, then we need to remember we need to normalize the data. There are lots of advantages to norm. For the normalization process. That is why we have to normalize the data. So what are those advantages? Let's see this thing. We have some Excel representation. I'll be opening that Excel and I'll be showing you how we can prepare a denormalized data to normalized data. That is fine. But what is the advantage? Why we should move to normalization process? Okay, so here are those advantages. Data normalization is the process of recognizing the data within a database so that users can utilize it for further queries and analysis. So those are the steps and the helpful, things on top of normalization. Duplication may be eliminated. In a particular table, if I want that table to be normalized in nature, we must have to remove the duplicate so that in a particular table, duplicate row should not be there. Duplicate record should not be there. So when we are storing the data in normalized way, the resultant data set should be in smaller size. Okay. So suppose in a cloud, I purchase some of the spaces for a particular database. And if my data is not normalized in nature in that database, I need to pay much more dollar. Okay. But if I just store the tables into the database after normalizing, then I just have to pay very less compared to the previous one, because when we are normalizing the table and saving it into the database, it should take less space. Okay. Uh, Third point, minimize, avoid issues with the data modification. If you want to go ahead with a quick modification of the table and all, then it should be very simple for us. And fourth point, the query makes easier. Query means the language to retrieve the data from a particular table. So if we are just doing any SQL queries on top of that particular tables, which are normalized in nature, our query should be much more faster and easier as well. Okay. So those are the I mean pros of particular normalization process. So when we are preparing a denormalized data to normalized data, we just have to go through. As of now, I'll be just showing you two steps to move it from denormalization to normalization. The first step is first normal form. The second one is second normal form. First normal form, after the first transformation from denormalization process, we need to bring the table in first normal form. Okay, with the mentioned process over here. So when the table is in first normal form, then we need to apply again some logic to make it second normal form. So this is the process. So how we can go ahead with the denormalized table to first normal form table. Let's go ahead. I'm just opening an Excel sheet. I put some examples over there. I'm representing the same in front of you. Okay. Okay. Suppose this is a table. This is a table, a particular, I can tell you that this is a particular data set where I have collected it. It's from a tuition batch, just like this, with few of the record samples I am having with myself. So over there I have student ID, student name, course ID, course fee. Okay. Student ID is this, student name is this, course ID, I means a particular student is learning which courses, and the course fees they need to pay. So the table is denormalized in nature. Why? Let's check what is the topic in first normal form. To make a particular table into first normal form, we need to check whether a particular cell should contain a single value or not. Over here, those particular cells are containing single value over here. That is fine. But you can see from the course IDs, this particular cell, it's not containing single value. It's having multiple value. That is why it's denormalized in nature. It's not in first normal form. Okay. Second topic, each of the records should be unique. Whatever record we are inserting over here, that should be unique in nature. So over there you can see row number 2 and row number 5. Those are duplicate in nature. Maybe they have inserted the record twice in a same table. Okay. This should occur, lots of issues actually for aggregation thing. So when I'll be checking how much amount needs to be paid by this particular student, Sonu. Then suppose I overlook that there is two entry. I'm just putting some formula I'm adding for Sonu's course fees. I'm just directly adding with these two and these two again, and I'm telling Sonu that this is your course fee and you need to pay this. If this is the scenario, then it is very bad. So that is why while storing the data into target table or normalization table, we need to think about that thing. First point, a cell should be containing a single value, single element, and each of the row should be unique in nature. If there is duplicate row, we can eliminate one of the row. Okay, so to be first normal form, those are the two things we need to remove. First thing we need to remove we need to separate these things in separate rows. So that is why I came into conclusion for this table. The same table I just represented in first normal form. I have deleted this record. First, you can see there is no entry for 12 again over here. Okay. And the second thing what I have done, I have splitted the extra element. There are two elements. So this thing you just can see I splitted those two things A12 and 800 in these rows. I have accommodated these things over here. And in the next row, I have accommodated A13 and 300. Okay. Similar things for Raj. But those are not duplicated in nature. You can see only student ID and student name are duplicated. But here the difference is there for course ID and course fee. That is why the entire row is not duplicated. When we are just segregating two course IDs or two course fees into different records. Okay. Till now, it's understandable for everyone. Aditya, Dipti, Ramya, Rishita, any doubt? Srija. Okay, I hope no. So now we have find our table is in first normal form from this denormalized table. Okay. We completed this thing. Next thing, we need to prepare our table in second normal form. First thing we need to check, where we'll be just going ahead with second normal form. The first criteria should be made that our table should be in first normal form. In my example, it's already there. We just converted this thing to first normal form 1M, 1NF. Okay, I can say this is the conversion of 1NF. Okay, okay, I cannot put any implied sign. Okay, fine. Just putting this. Okay, and after that, I can put this thing. Yeah. I'll be just trying from first normal form to second normal form. So what are the different thing? Let me just cut it, paste it over here. In second normal form, what are the criteria? It should be first normal form. And the second thing is, we need to check all the columns. We need to identify the primary keys of the table. And we need to check whether all the columns inside the table are fully dependent on the primary keys or partially dependent on the primary keys. If there is any partial dependency or there is a particular column is not totally dependent in a particular on top of the primary keys, then we can eliminate those columns from that table and we can create another data set. So this is the second normal form. Let me repeat once more time. This is very, very important. We need to identify the primary keys in the first normal form, the primary key of the table in the first normal form table. Okay. And we need to check the other columns except the primary key, whether the other columns are totally dependent on the primary key or it's only partially dependent. If it's the scenario, it's partially dependent, then we have to remove that columns from the data set and we need to create another data set for the same. Let's check it out. So over here, okay, one more thing, student ID. Here student ID is not the primary key because individual students are learning multiple course IDs. That is why we need to mention 12 over here. So that is why, okay, someone is having confusion on top of primary key. I'm just telling once more time over here. Primary key is the, it should be the unique, it should contain unique data respective to each row. Okay, or we can say it's a row identifier. For student ID, you can see it should be unique if I just put in this way. Okay, for this scenario, it's unique, but over here we have multiple courses assigned to each student. That is why we have segregated the data. And now student ID is not a primary key anymore. We can say course ID and student ID, the combination of both of them can be a primary key because the things are duplicated in nature. 12 is duplicated in nature just because of this course ID. But if I just combine this student ID and course ID, 12A12, 12A13. So this combination is not duplicated over here for each of the row. So from this thing onwards, I can say that the combination of student ID and course ID is a unique row identifier for each of the row. Are you all agreed with that?
Yeah.
Okay. So that is why it's called, there is another key concept. The key I'll be coming again. Just to let me, this is called composite key. A set of columns used to uniquely define the rows of the table. Composite key can be a primary key. Over here, in this scenario, the combination of student ID and course ID, this composite key is the primary key of this data set. Okay. Now I need to check the dependency of other columns on top of this column. There we can find that the course fee is not directly dependent on the student ID or course ID's combination. Student ID and course ID's combination. Okay, a student ID cannot be dependent on the course fee. I mean, the other things I just want to say, course fee is not dependent on the student ID. Course fee is totally dependent on the course ID only. It's tagged with the course ID. A11 should be having a course fee. A12 should be having another course fee. That is why I segregated this thing in another data set. So when I'll be segregating, it should be in this manner, which is also duplicated in nature. You can see if we just segregate this data set, again, you can see the repetition A11 500, A11 500, A14 700, A14 700, because this is earlier it was been tagged with various students. So when we segregated it, we can be having duplicate. Now remove the duplicates to make it a first normal form. This is the one. So we have splitted from the main data set the course ID and course fee combination. And in the main data set, I remains in this scenario. Okay. So we have removed the partial dependency. The course fee is the partial dependent on top of the composite key over here or the primary key on this table. That is why we have splitted this thing over here in this manner. Okay. Now the question may arise, if we split this thing up, how we can set relationship? This is because of course ID. We have the common column course ID I told you last day. In a particular relational database, this is the scenario. We need to, when we are splitting this thing up or when we are normalize this thing, we need to put the common columns so that when required, we can quickly check. Okay, the question may arise. What should have, Pankaj needs to pay how much money at the end of the month? Okay, I need to come check from this table which particular courses Pankaj is availing A11. Then I need to go through this table again. A11's course fee is 500. So Pankaj has to pay 500. For Sonu is learning A12 and A13. So Sonu had to pay the summation of these two course fee. Okay. When we'll be learning SQL, we'll be learning how to join between multiple tables. Okay. So there we'll be joining these two data set and pick the desired records for us. So here we are just checking data from here and we are matching the thing from here and we are picking this value when it's required. But just suppose we should not be only having those 5 records. We should be having maybe 200 records, 300 records, maybe thousands of records. There, it's a bit difficult. It's a bit difficult. It should be a time-consuming method. If you're working in the Excel by this manner, when we'll be learning join, then we'll be joining between common keys and picking up the another column. But for storing purpose in the database, we need to maintain in this format. We need to remove partial dependency between individual tables, partial dependency of the columns to the primary key, and we need to split it up between multiple tables. Okay, now I can say the combination of these two tables are in second normal form. From this table to this table, this is the source data we are receiving. But when we are storing the tables in the data warehouse or data marts, we have to store in this manner. It's an efficient way of saving the data into the database. Okay, the advantages I already mentioned in the last slide, but this is how we can make it a second normal form table. Any doubt from anyone till now? Second normal form, it's simple. I have another example over here. This example I was discussing yesterday. Suppose uh, a particular shopping outlet, what kind of data they are generating in a particular table. So they're creating an order ID. So while doing the billing information, while doing the billing part, they are having order ID. Suppose order ID is the primary key for that table. And what kind of other information? They are putting the customer name, customer contact number. They're taking our phone numbers and all. They're checking if there is any reward pointers available or this kind of thing as well. The customer addresses as well. They're also capturing which kind of product they have purchased and what is the cost of the billing. Rather, I can say billing cost here. Okay. So these are the information a particular uh, maybe when they are inserting the record in their source systems in a shopping outlet, there are some UI. Okay. So they are putting those information and they're pushing the data, maybe some databases, which is not normalized in nature. Suppose this is the database, but this is not normalized in nature. Let me bold this thing as those are the column name. Okay. So those are the column name. It's already in first normal form. I can see no elements. There are no two elements or more than two elements in a particular cell. So this is fine. Even there are no duplicates in each of the row. I have only entered 2 rows just for example. Now I can see there are lots of partial dependency. Okay. So just like customer, those many customer information I should not keep in order table. If I think this is my order table, okay, in order table, we just have to be specify, especially on top of order. So and it's not directly dependent. Suppose customer city, it's not directly dependent on the order ID. Okay, so what I can do, I can create, this is another example of second normal form so that your concept should be clear. So I'm keeping order ID in one column. Rather putting all the customer related information, I can keep it separate with a customer table. For customer table, I'm giving a particular customer ID, which should be their primary key. Okay. Or which should be a row identifier. Each customer can be from a shopping outlet. I can give a customers as a customer ID. Maybe the customer ID, maybe their phone number, or maybe I can give another ID. Suppose one for this customer, two for this customer. The same kind of thing I can introduce over here as well. Irrespective of putting all the things in a single table, I can just put customer ID over here. This order ID is fine. I'm putting customer ID 1, customer ID 2. Okay, let's shift a bit. Okay, let me enter one more row. So this is order table. This is order table. This is customer table. Okay. Okay. And then customer related information I'm putting over here. So when it's required, if I need to check which particular person has purchased that particular order or given that gave that order, then I can quickly check which customer ID is tagged with here. So I can check it's one. Then I'll be going to customer table. I can get details of the customers. Okay. I do not need to put all the things in the order table over here. The table should be very huge and it should not be good to maintain. Or I can put duplicates when I'll be processing further, because we should not be only two records. We should be having lots of records there. So when we'll be processing further, we need to, there should be difficult to maintain the data in this manner. That is why we are normalizing it. The next thing, product name. Okay. Here I can introduce some more thing. Product name, I can introduce product brand as well. Just let me, first I'm putting it over here. I'm putting billing cost. Give me some second. Just doing this, clear your concept. Over here, I'm putting product brand. Okay, so biscuit I can put Britannia. Cold drinks I can put Pepsi. Okay, so now for this thing, for the product related information, I can store this thing in another table called product table. Oh, sorry. Okay, I'm putting some row identifier there as well. This product ID or product code, anything I can put. I can put some code for each of the product. So for the Britannia biscuit, I'm just putting a product ID, suppose 111. For cold drinks, I'm putting 210, having this brand. Okay. But there should be lots of things. They are putting the product code, maybe a particular volumes, particular brand, maybe 600 ml Pepsi's cold drinks are having this product code. This kind of thing might be having. I'm just for simplicity, I'm doing these things. And I'm also putting the same thing over here as well, because the main table should be containing this thing. As well as I'm involving for a particular order, there is direct dependent of this thing, how much cost for a particular order, or for this order, a particular customer set has paid what particular amount. So this should be directly pushed over here. So the entire data set I have segregated in this manner. This is product table. This is customer table. And sorry, this is order table, this is customer table, and this is product table. So whenever I need all the information, suppose which product the part in that particular order has been purchased, I have to join between order table and product table, and I need to fetch those extra thing from here. Okay, what particular customers had purchased what things on that particular billing number or order number, I have to join these two table and fetch those thing. So this should be the concept. Now our database is normalized in nature. There is no partial dependency over here between each of the columns. Okay. The concept is clear for everyone till now. It's another example for second normal form. If no, please tell me. If there is any doubt or anything, please tell me. Okay. So it's order table, it's customer table, it's product table. Now the question is I think it's understandable for everyone, as I did not receive any question from any one of you. Moving on to the next slide. Keys in SQL. Okay. Keys I already mentioned primary key and composite key just before this slide. Let me once more, repeat over here. We did this example. Okay. Let me ask you the question. Anyone? Okay, Aditya. Aditya, from the customer table, which is the primary key over here? Aditya, are you there? I'm not sure whether I'm pronouncing it correct.
Customer ID.
Correct. Customer ID is the primary key. Why customer name is not the primary key? Why should we not have to put customer name as a primary key? Anyone?
Because names may be different. There will be so many names with the common, but ID will be unique.
Correct. Yeah, name should be. You told name should be. Same. Maybe we have same customers in different location. So that is why when we are storing the database, maybe this Rintu Kumar, there is another Rintu Kumar with different location. So yeah, you are absolutely correct. Customer ID should be unique key. But over here, the same customer ID is the unique key in this table, customer table. But I'm pushing this customer table, customer ID over here as well. But in this order table, order ID is the primary key and customer ID should be recognized as a foreign key. Customer ID is the primary key in the customer table, but customer ID is the foreign key in order table. That is the concept of foreign key. Why we are putting foreign key over here? Just to make the relationship between order table and customer table. Similar kind of thing in product table as well. In product table, product ID is the primary key because this is the row identifier. For Britannia biscuits, maybe to 500 grams quantity. There are lots of quantity for the same things. So I just put a product code for that particular product. Okay. So when I am, so product ID is the primary key over here for this table. But when I'm just storing the same product ID information in the order table, it's working as a it's working as a foreign key in order table. we are putting the order ID over here just to set relationship between order table and product table by this common key product ID. Okay. Yeah. So someone is having doubt. Let me just check. Someone told me that they have some doubts. I mean, she has some doubt. I mean, I forgot the name. It's Ramya.
No.
Someone just told. I mean, doubt having. I mean, what is the difference between primary key, composite key, and foreign key? I hope the doubt should be clear. If not, please tell me.
Yes, it's cleared.
Okay, it's you. Okay. Yeah. What's your name? It's Venugopal or not sure.
Bharti?
Okay, Varti.
Yeah.
Yeah. So the doubt is clear. The composite key I just mentioned, composite key should be combination of multiple columns. Okay. As for the first example I told you, we can put maybe there should be multiple columns, cannot be two columns, can be multiple columns as well. Based on the project requirement, we can identify whether a table should be containing composite key or single columns to be primary key or just like this. Okay. Okay. Now I'm moving to the topic to the database. Okay. First of all, I'll be recommending you to install one database in your systems so that we can go ahead with the hands-on part. So as of now, as MySQL database, it's open source and it's very, I mean, it will take very less space for the beginners to, not only for beginners, we can also in our project purpose also, we can use MySQL databases as well for various aspects. Okay, so just download the same thing. It's open source, free software. Download the installer and install it in your systems. So while installing it, please install this, the big one, this one, not this one, 331 MB, and install it. It's, I mean, the installation should be very simple. Within 10 or 15 minutes, the installation should be done. Just one thing needs to be remembered. I'm just pinging this thing in the chat. Whoever did not install this database, please install the thing in your systems. Over there, just download this version. I hope everyone should be having in Windows systems. Windows operating systems actually. So install the same thing at your systems. Okay. While installing the thing, you need to configure the password, the database password there at the beginning of the installation. So put it and remember it properly, because each time when you'll be logging into the database, they will be asking for the password. Okay. So let me log into my database. I already installed it. MySQL. Okay. Okay. So MySQL database, when we have installed it, along with MySQL database, we are receiving 2-3 more softwares. You can see over there, the database is getting installed, but to retrieve the data from this database, we can have MySQL command line client. So from command line, we can put the query, it's fine. Otherwise, the recommending one, we can use the another software called MySQL Workbench. So it's a UI where we can directly connect MySQL database. Okay. So I can query on top of both of them. But this is a Linux based thing, a command window kind of stuff. It's not very user friendly. So that is why I can take this ID, MySQL Workbench. So all the things should be installed from this installer. Whatever I have pinged you, you can directly install from there. And then I'm launching MySQL Workbench. I have previously configured these things. So you can also configure when you'll be installing it. The database should be configured at your systems. But just to I mean, you need to remember or recall the password, whatever you are putting these things. So each day when we are logging in, it will be asking the same password. Okay. So I'm putting it over here. I'm logging in. So this is how the database should look like. I mean, the software should look like. In the left-hand panel, those are the different database schemas. Those are called database schemas. Okay. There are separate database schemas. When you will be installing the thing, you can see there are by default 3 or 4 database schemas should be there. What I can recall, this database, world, those are the databases which are already there. You can remove these things from here, it's fine. Suppose I have created this database by my own. I can remove this thing, just right click on it and delete it. Drop schema. Drop now. Just this has been dropped. Okay. So there all the database are mentioned over here. Inside the database, if I just click on there, or suppose I'm clicking on here, I can see those are database objects. Different database components are available over here. So what are the database components? Components can be table. This is the most important thing, tables. We are storing the data in tabular format into this database. That is called tables. We have this many tables, 1, 2, 3, 4, 5. I can just select rows. There is no such rows. Let me pick up this thing. Okay, so I just select the query parts. I will not be telling today. So I can, those are the rows or data that have been stored in that particular table. Okay. And the right hand side, this is called, I mean, there will be writing the query. This is query explorer. We'll be writing the query, we'll be executing the query by this button, and our output will be present at the below location, this location. In this pane, when we are selecting a particular table, it's showing us what are the table name with bold, and it is also showing us the columns available with that table and their data type. What are the data types? How the columns have been defined? We'll be discussing the topic on Monday onwards. Okay, so over here in this pane, we can just see the metadata of this table, metadata information of the table. Okay, so this is a demonstration of a particular database, MySQL database. Inside the database, why we should use database? To store tables, to store the tables over here. Okay, and uploading the data, it's easy access. And in the market, there are lots of databases are available, just like MySQL. Over here, we will be demonstrating on top of MySQL, there are Oracle databases, Microsoft SQL Server. Some of you told yesterday that he's quite efficient with SSMS. It's a Microsoft tool, Microsoft SQL Server. SSMS is a tool, just like over here, I'm working on top of this tool to connect MySQL database. This is not the database. Database is stored in backend in file format, but we are using this tool MySQL Workbench to connect with MySQL database and do queries on top of that to retrieve information. Similarly, we have SSMS, that is called SQL Server Management Studio. This is another database tool to retrieve data from Microsoft SQL Server. Okay. Similarly, we have Teradata, we have Postgres, we have Sybase, Sybase, we have DB2, we have Redshift, we have Snowflake. Snowflake is another important database nowadays. Okay. Lots of projects are using Snowflake database. So those are the different database based on different requirements, based on different project aspects. The architectures are choosing a particular database in their project. Not a particular, maybe there are multiple databases. for different subjects. Okay, but just to let you know, I told the same thing. All the databases, when we will be writing SQL query, it's almost same. There should be some difference on top of some inbuilt function for each of the databases, but the overall concept, the overall functionality are same. So if you learn the SQL query on top of any one of this database, it should be 90% or more than 90% same. You can do queries on top of any of the databases. The main concept should be clear, but when they're launching each new database, they're having some new features as well. So they have some new inbuilt functions with them. So if we are just working with that one, along with our knowledge, we just have to go with some other documentation for individual databases. Okay, if we have some extra time, I'll be covering Snowflake as well. It's a portal-based database. We can just directly log into the portal and we can create our Snowflake account. Over there, we can go ahead with some features on top of Snowflake. Mainly the topics from tomorrow onwards would be totally focused on MySQL database. But if we have some extra time, I'll be definitely showing you Snowflake databases as well. But it's almost similar for every database. Okay, database schemas I have already shown to you. Those are database schemas. In the left hand side, we can create new schemas. How to create new schemas? Just right click on top of any of the database schemas and there's an option create schema. Okay, and put the schema name there. New schema or put anything. New schema underscore test. I'm putting this thing. Okay, just applying it over here. Applying it in the backend, it is throwing this SQL query. I'm not showing you the SQL query today. SQL query I'll be showing you the day after. On Monday onwards. So I have created the new schema. This is a new database. I can store tables over here as well. Okay. Or I can also create the new schemas by typing the thing over here. Create schema name. And just execute the query. The new schema should be available over here. Okay. Schema is a different database instance that is represented by schemas. The name is schema. It's different database instance. In the same MySQL server, we have those many different database instances available. Okay. What are the different database objects? Inside one schemas, I just told you, showed you over here, there are tables. Not only tables are there, tables is the basic unit of the data source. That is fine. We'll be mostly focusing on the tables only. But there is not only tables, there are views, there are store procedures, there are functions. So those are different database components available in a particular databases. Okay. So we'll be gradually learning these things one by one, starting from table. Okay. Any doubt so far? We are almost near to the end of the session for today. Any doubt on normalization, keys, databases? No doubt? Okay, I hope everything is fine. So let's install the software. I hope there will be no issue. Download it and directly install it. It should take 10 minutes. No, I'll not be sharing the PPT as of now. It's the same. It's very simple actually. I'll be sharing the recording with you. So that the recording, you can watch the recording. I'll be sharing the recording to the admin team of Teradata. And they'll be storing it to some link, maybe some cloud space or just like this, and you can check the recordings from there. Okay. Okay. Hope there is no doubt. Install the same software so that when we'll be doing the hands-on part on Monday onwards, we can go through this thing parallelly. You can also check it out at your systems and can also do the same practices at your site too. That's all for today's session. Let's connect on Monday with having the more exciting, languages, SQL languages over there. Thank you, everyone.
Yeah.
Bye-bye.
Thank you very much. Bye.
Happy weekend to everyone.
Yeah, have a nice week.